compute the double integral over the region R of x to the fourth plus y to the fourth dA, where A is the area element in the region R. And R is a rectangle where x is between 0 and 5 and y is between 0 and 1. So this is a double integral, and by Fubini's theorem, if you're integrating over a rectangle, a continuous function, then you can write this as an iterated integral. So we could go integral x to the fourth plus y to the fourth. And now instead of saying dA, we could do a dy integral and a dx integral, or we could do a dx integral followed by a dy integral. So if we put dy first, then that means the inner integral is with respect to y, and y goes from 0 to 1, and the outer integral with respect to x goes from 0 to 5. And if we do the dx integral first, then x goes from 0 to 5, and y goes from 0 to 1. And these should give us the same output. Let's do it both ways and see that for ourselves. So this is the integral from 0 to 5 dx of the inner integral. So this is just a one variable integral. The variable is y, which means we're treating the x to the fourth here as a constant. So the integral, the antiderivative of x to the fourth, which is a constant, is just that constant times the variable y. So x to the fourth y, and then the antiderivative of y to the fourth is y to the fifth over 5, and now here we have to use the endpoints 0 and 1. So we're going to get out of this a function of x. We're going to be plugging in 1 for y and 0 for y. So when we plug in 1 for y, we get x to the fourth plus 1/5, and then minus, plug in 0 for y, and when we plug in 0 for y, we get 0. So we're left with just x to the fourth times 1 plus 1 to the fifth over 5. And here we have an elementary integral. The antiderivative is x to the fifth over 5, and the antiderivative of 1/5 is 1/5 times x. We have to plug in 0 and 5. When we plug in 0, we get 0 again, so we just plug in the 5 to the fifth over 5 plus 5 over 5. And 5 to the fifth over 5 is 5 to the fourth. And 5 to the fourth is 625. And so adding 1 gives us 626 for the answer. Okay, now let's try it in the other order. So with respect to x first, so that means we're thinking of the y as being a constant. And that means that we have integral 0 to 1 of, and then we'll have an integral with respect to x here that we're going to compute. The antiderivative of x to the fourth plus y to the fourth with respect to x is x to the fifth over 5 plus y to the fourth times x. And we want to plug in for x 0 and 5. So when we plug in 5 for x, 5 to the fifth over 5 is 5 to the fourth as we did here, and that's 625. And then plus 5y to the fourth. And when we plug in 0, we'll get 0. So we want to integrate from 0 to 1, 625 plus 5y to the fourth dy. And that's 625y plus y to the fifth. From 0 to 1, we plug in 0 and get 0. And we plug in 1 and we get 625 plus 1, which is 626 again. And that ends the problem.